So I'd like to welcome you again to today's lesson. So we're gonna discuss limiting in excess reagents, right? So to start off, let me make an example. Usually, if you want to make a sandwich, how many slices of bread do you need? Let's say you wanna make a sandwich. How many slices of bread do we need? Let's just say two. I mean, I mean, um, uh, some of us, we might prefer four. Some of us might prefer six. But let's make a standard sandwich. It's gonna be one slice of bread. Yes, and then it's gonna have some cheese, right? You need at least one. What do we call it? One. Yo, English. Yeah, one. Cheese. You understand? One cheese there. So this is what we have. Our nice sandwich. It has two slices of bread, and then it has one sachet, or just one cheese. Let's just call it one cheese. This is a normal situation. So this is an issue of saying, if I want to make a sandwich, I have to look at the available amount of bread. Did you hear that? I have to look at the available amount of bread. So I have two slices that are available. And then how much do I need to make bread? I need two slices. So this is a perfect situation, because the amount of slices I need to make sandwich are exactly the same as the amount of slices of sandwich that we need to make bread. Let's put it in another way. So let's just say you had four slices that were available. Okay, you have four slices that are available. If you have four slices, this is still your sandwich. This is the cheese, and then that is still two slices of bread. But then you have two slices extra that are available, right? So four are available, but how many do you need? You need two slices. Those are the ones that you need, right? So you have four, but you need only two. So are you going to use the four slices? No, unless if you want to make a sandwich whereby you can barely taste the cheese. I mean, if you take this slice here, you put it here, ne? Then you take this slice here, you put it there. I'm sure you very well know this situation. When you are eating this, like you are just eating bread, the cheese, barely can taste it, right? So I believe we wouldn't want that. We just want, we'll just simply take our two slices and make the bread. So these ones that we do not use, that we do not need, right? These are called excess number of slices. You see, those are the excess number of slices. But I want to show you something. I want to show you something just before we move forward. Let's say I have pieces of bread that are available. Okay. Let's say I had 8 slices. I have one cheese, right? How many sandwiches am I gonna make? It's just gonna be one. So you would take exactly again. You take your 2 slices and make your sandwich, but then the excess now is going to be how many? It's gonna be 2, 4, and 6. These are slices that are in what? These are in excess, which means we do not need them. That means they remain after you have eaten your sandwich, they remain there. They are not used. You understand? They are not used. Right? So, um, this from this alone, it can tell us one of the most important things in chemistry is that if the amount of available, if available is greater than needed, then we have what we call an excess reagent. So, which tells us that that thing is in excess. I repeat, which tells us that that thing you are focusing on is in excess. In this case, our slices of bread are in excess because the rest of the 6, we do not use them. We only use the 2. But tell me something. Yeah, so what we're saying is that the amount of slices of bread, they are in excess because we have more than what we need to make a sandwich. Did you get it? Perfect. But let's look at it a bit more. What if what if I had 2 slices of cheese now? That means here is a cheese here. How many sandwiches are we gonna make? Still with our 8 slices. 2 sandwiches. Okay, so that means we'll take 1 slice. Oh, my slice now, I've sliced it. Okay, let's yeah, these slices. Okay, let's just remove this. Yeah, good. Yeah, so now I've taken 2 more slices. Then now I've made 2 sandwiches. As you can see, I've made 2 sandwiches. How many are in excess? It's gonna be 4 slices, which are left unused. Right. So, wait a minute. Can we say that actually the excess number of slices, right, depends on how many cheese you have? Because if you have 3 cheese, then you have 3 sandwiches. It reduces the excess. You understand? So, which tells us that these 2 things, they are depending on each other. Yes, talk to me. Okay. Yeah. So that is what we're saying. So actually, the number of cheese that we have, right, tells us. Like, I'm gonna write it in. Let me write it here as a nice statement. This is my final statement on this. The amount of cheese that we have determines how much. Okay, let me just do this. The amount of cheese that we have determines how much of the slices of bread we need. That's very important. The amount of cheese that you have actually determines how much of the slices of bread you need, of which the slices of bread are more, right? They are more, the amount of cheese is less. So, which tells us that the one that is in more quantity, that is the excess reagent, and then the one that is in less quantity becomes your limiting reagent. So this means that the cheese is the limiting reagent. In other words, the cheese runs out first before the amount of slices runs out. You understand? So hence we say that the cheese actually determines how many sandwiches you make, which means the cheese determines how long the reaction is going to take place. If the cheese runs out, there is no more reaction. If the cheese runs out, there is no more sandwiches. Right? So that is a limiting reagent. The limiting reagent tells us that it means we have two things. Let me go back to chemistry. Let me give you an example here. We have 8,4 grams of nitrogen, right? Which is this one. And then it reacts with 1,5 grams of hydrogen, which is this one. So both of them, they react with one another, right? This is the reaction part whereby they are forming something. What are they forming? They are forming ammonia, which in our case we're forming a sandwich. But between nitrogen gas, but they said it's an unbalanced though. So how do we balance this? I think that is the first question. How do we balance this? Can you quickly balance it? Uh-huh. 1, 2, 1, 2. What do you think we're gonna put the 2? I mean, this is 2 nitrogen atoms. Then here you have 1. So remember, I can't put 2 here, but rather I have to write 2 outside. Then this means I have 2 nitrogens, which is fine because also you have 2 nitrogens. But remember, the 2 does not only affect this part, it also affects the hydrogens. Now you have 6 of them because 2 times 3 is 6. So we also need 6 hydrogens this side. Because we have 2, we can't just write 6 here. No, we have to put 3 here so that when 3 multiplies 2, you get 6 hydrogens. Then it's balanced. So we have quickly balanced it. Please do not work on a reaction that is not balanced because you will end up getting 0. Right. So the second question asks us, which reactant is a limiting reactant? Which tells you that which reactant determines this reaction. Or to put it in another words, which reactant is going to run out first between nitrogen gas and hydrogen gas? Now, you might want to look at this and say, okay, I have 8,4 grams of nitrogen. And then I have 1,5 grams of hydrogen. So, this is simple almost. This looks like hydrogen is less. So it means hydrogen is like the cheese. If you have less cheese, or the cheese when it runs out, then remember, we are done with making the sandwich. Similarly here, when the hydrogen runs out, it means the reaction is over. It's complete. This tells us that this is the excess reagent and then this is the limiting reagent. But can we just do that for 4 marks? Or 3 marks? No. That is not the way to do it. It's deeper than that. So we're going to dive deep into that. So let's develop a method that we're always going to use for us to determine the excess and the limiting reagent. But a basic understanding is that the limiting reagent is the one that runs out first. The excess reagent is the one that is in more quantity. Right? Think of when you're trying to cook pap. If you're cooking pap, there is water, there is milli meal, right? Milli meal, you usually buy it in a 10 kg in a 10 kg you buy 10 kg of milli meal. But when you're cooking pap, do you use the rest of the 10 kg just for 4 people in the house? Can you cook all the 10 kg? No, unless if I don't know how many people you'll be cooking for, but you need at least maybe just 2 cups or 3 cups. You understand? Then your pap is good to go. So this tells you that the 10 kg of milli meal is in excess because it's more. And then the water that you're going to use, obviously, if you had let's just say you had a liter of water or 2 liters, right? When that 2 liters of water runs out while you're cooking your pap there, then it means you are done cooking. You understand? You don't cook anymore. So that tells you that the water becomes the limiting, because once the water runs out, then you are done cooking. Another example could be flour and oil. Let's say you're trying to cook amagwinya. Is it amagwinya? Yeah, something like that. So you'd usually boil your oil such that it's very hot, and then after that you take flour. Obviously you're gonna prepare the flour first, right? But you don't use the whole 10 kg of flour, right? You just use a certain amount of flour that corresponds to the amount of oil that you have. Usually you can have a liter of oil or 2 liters of oil. Once that oil, maybe let's say, runs out, then you no more are cooking amagwinya. You understand? So that's how it works. It tells you that the water or the oil becomes the limiting reagent, because once it's finished, the reaction is complete. Whereas the flour is the excess, because it remains after the reaction. So after making your amagwinya or pap, you still have some flour that is left. You still have some mini meal that is left. I hope that it makes sense. So similarly, in reactions, that is what is happening. So between that and that, there is one that is going to run out first, and once it runs out, then the reaction is complete. So that becomes your limiting. But we can't simply look at these grams here and say hydrogen is going to be the limiting because it's in less quantity. You understand? What we actually need to do is to do some stoichiometric calculations. So what do we do? The first thing is that you need to, so these are the steps. You might need to note these down. Number one, convert all reactants to moles. That is the first step. You're gonna use this formula. So let me just try to write it a bit this side. So you're gonna use this formula: N is equals to M over the molar mass. Okay, that's the formula you will use there. So you convert the reactants to moles. Once you are done doing that, what is the second thing you do? Understand that those moles, we call them the available. That is what is available. You understand? You have 8.4 grams of nitrogen that is available. You have 1.5 grams of hydrogen that is available. So by converting it to moles, we call them these are called number of moles that are available. Okay, number of moles that are available. So it's N, and then you write a subscript, available. This is what we have. So it's more of like you have 2 liters of oil and you have 10 kg of flour. That's what you have. So you're just changing those masses to moles. Convert everything that is given, as long as you're converting the reactants, convert them to moles. After you're done doing that, what do? Use molar ratio to compare them. So you would say number of moles of reactant 1 is to number of moles of reactant 2. Okay, perfect. Then what do? Write in the calculated available moles. So here you're going to put one of the available moles of the reactant 1. Ne? And then here you put X. After you're done doing that, you're gonna we can just say actually compare them, put in brackets, calculate X. Right, calculate X. Once you have calculated X, what do you then do? Compare the N available, compare the number of moles that are available available, compare that to x. By the way, x is the number of moles that are needed. Ne? These ones are the ones that are needed. So if you do that, ne, this is what you then are simply going to do. You shall say if number of moles that are available are greater than x, ne, which means the moles that are needed, then so if you have more than what you need, listen to that, if you have more than what you need, that is your excess reagent. That is the excess reagent. But then if you have if those that are available, ne, are less than what you actually need, moles needed, then you are dealing with a limiting reagent. Great. Those are the simple steps to always find out which one is the limiting and which one is the excess. Yeah, it seems very much complicated, ne? But I can promise you it's actually not. It's not complicated. Okay, as soon as you are done with taking those notes, ne, please tell me so that we can follow along, ne? You can just raise a hand that say I'm done copying that. Great. Okay. Right. So we must have that. So we just gonna go through them step by step using that. So since you're gonna have these, right, that is going to be very much helpful as we go through them. So let's actually start. So the first step that we need to do here is to convert all the reactants to moles. So our reactants that we have, it's nitrogen gas and hydrogen. We need to convert the mass that is given. Remember, this is mass. We need to convert the mass that is given to moles. Please note that, you use this formula if for the reactants you were given masses. But if for the reactants you are given volume and you are told that it is at STP, then you might want to use this formula to convert those reactants to moles. I repeat again, if you were given volume of nitrogen, volume of hydrogen, and you were told that it is happening at STP, then you're gonna need to use this and put the volume plus molar volume, which is 22,4. You understand? From your it is there in the table of constants, right? So you might need to use that formula. But if perhaps you are not given volumes, let's say you are given concentration, maybe you are given concentration of this one and its volume, you are given concentration and its volume, you might want to use this formula, this one, and then write it as N is equals to C times V. then you'll be able to convert the given concentration and volume to moles, right? Remember, moles are very important, right? So that is it. But in this case, we are dealing with masses, so we are definitely going to use that formula for mass. We're going to use that one. So let's start using it then. For nitrogen, let me write it here. Start our 1.1. This 1.9, 1.2. Let's say it's 1.2.1. So we need to know which one is the limiting. So I will start. The number of moles of nitrogen gas is going to be equal to the mass of nitrogen over the molar mass. Now what is the mass? The mass that is given is 8,4. What is the molar mass? Remember that the molar mass is the mass of nitrogen that you find on the periodic table. So I believe if you go to your periodic table and try to find nitrogen there, I believe the mass for nitrogen should be, what is it there? Is it 14? Should be 14, ne? But then, perfect. But then because there are two nitrogens, you might want to multiply that 14 by 2. Right? So therefore, you're going to have 8,4 divided by 28. What do you get in your calculator? Remember to round off to 4 decimal digits, ne? So is it just 0,3? Okay, perfect. So these are the number of moles for nitrogen. Now we're gonna need to get the number of moles for hydrogen. Let me just be moving this side. So the number of moles for hydrogen is going to be equal to mass over the molar mass. Now the mass for hydrogen that is given 1,5. The molar mass, when you look at hydrogen, the molar mass is 1. But because there are 2 of them there, you need to multiply by 2. Please note that the molar mass, you don't multiply it by these numbers here. Those, you don't put them when you're calculating molar mass. Okay? You only put these ones, the smaller ones, the subscripts. Those are the ones you multiply with there. Okay? So what do we get for this one? Great, 0,75 moles. Perfect. So far so good. Please remember, we said limiting reagent is the one in less quantity, whereas excess was the one in more quantity. But we don't compare them using these moles and saying that nitrogen is small and hydrogen is more. You understand? Then you'll be like, it means hydrogen is the excess. No, you don't do that. You go to the second step. You need to do the molar ratio, ne? So you're going to say number of moles of the first reactant is to number of moles of the second. In this case, we're dealing with nitrogen and hydrogen. So we're going to say number of moles of nitrogen is to the number of moles of hydrogen. What is their ratio? The ratio is found on the reaction. Remember, on the reaction, it is 3 here. It is 2 there. What is here because it's not written nothing? Is that 0? No. That is 1. Right? That is 1. So the molar ratio is going to be 1 is to 3. Perfect. We did the molar ratio. We did it. Now we need to substitute the available and then the needed. We need to calculate the needed. So guys, at this stage, let me tell you something. You can either make nitrogen X and then have the moles of hydrogen here. Remember, these moles that you calculated, guys, please, let's remember that those moles that we just calculated, these ones and these ones, are the ones that are available. Available and then available. Right. They are the ones that are available. So you have 0,3 moles of nitrogen available, 0,75 moles of hydrogen available. So now you need to know how much of the nitrogen is actually needed. Then you compare the needed to the available. Or you can say how much of the hydrogen is needed, so that you can compare the available to the needed for hydrogen. So hence I'm saying you can either say nitrogen X, right, meaning needed. If you put X here under nitrogen, which means you are calculating the moles, right? Let me just show you. Which means you are calculating the what? You're calculating the moles needed for nitrogen. You understand? You're calculating the moles needed for nitrogen if you put X under nitrogen. But if you put this X under hydrogen, right? So if you do this, X here, and then you're gonna substitute here. So here you'll be calculating the moles of hydrogen that is needed. So it's totally up to you. You understand me? It is totally up to you which one you want to use, or which one you want to calculate for. X as hydrogen, or you want to calculate X for nitrogen. It's up to you. So I'm going to choose to calculate X for hydrogen. Now, for nitrogen, what I'm going to do here, I'm substitute the available moles. You remember this? We said you substitute the available. Now, so the available moles is 0.3 for nitrogen. Those are the available. Are we still together? Are we following? Great, 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 great. Now, let's calculate X. I believe we know how to calculate X. You know, it's cross multiplication. So you want to say X times 1 is going to be X. 0.3 times 3 is what? What do you get for X? 0.9 moles. This is what? Now be careful. This is what? These are the moles of, because X is hydrogen. It's moles of hydrogen that are what? That are needed. Moles of hydrogen that are needed. So now let's compare the moles of hydrogen that are needed to the available. So check the available. For hydrogen, you have 0.5 that is available. Nay, the number of moles that are available is how much? It's 0.75. And then hydrogen is how much? So what is happening there? Do we have more than we need, or do we have less than what we need? Or in other words, is the number of moles that are available more or less than what is needed? It's more than what we need. Let's write it. Ne?
Than what is have 0.75. I repeat, we need 0.9. We need
5. So which tells us that is hydrogen a limiting or excess? We go here. If the ones that are available are less than needed, that's the what? Limiting or excess? Okay, saying x's. Uh, any other view? Mr. Tabe saying limiting. Ladies, I really want to hear your opinion. Please talk to me. Which one? What's happening there? Yes, is that Miss Ori? Okay, limiting. Um, what about you, Miss Katleho? And yeah, limiting. Interesting. Miss Candy, any thought on that? Limiting or excess? Okay, no problem. Uh, okay, no problem. So this means that the correct answer is that hydrogen is the limiting reagent. So therefore, hydrogen is the limiting reagent. Why is hydrogen the limiting? Because the ones available are less than what we need. Yeah, yeah. Is it gonna be difficult to sink in? Nah, I don't think it's gonna be that difficult. Okay, uh, yeah. So what is available is less than what is needed. Ne? L- yeah. Yes. Oh, decimals. Guys, we count like this, ne? 0, 0,1, 0, 0,2, 0, 0,3, 0, 0,4, 0, 0,5, 0, 0,6, 0, 0,7, 0, 0,8, 0, 0,9, then we have 1, 0, 1, 1, 1, 2, like that. So that tells us that 0, 0,9 is bigger than 0, 0,8, 0, 0,9 is bigger than 0, 0,7, 0, 0,9 is bigger than 0, 0,1. Very important to know our decimals there because they might
Girls, B, Mr. Tao, talk to me. Which one is bigger there? Between 0,025 and 0,1. It cannot be B. Okay, yeah. So that is correct. It is B, 0,1. Because you see this one, 0,02 tells you that, great. You see, it tells us that this is bigger, 0,1. Okay, so very important to know that, right? Especially when you have to compare these moles. So in our case here, the one that is available is 0,75, and as we need 0,9, so it tells us that hydrogen is the limiting because we need 0,9, right? It means it's going to run out first. It's gonna run out first, you understand? And then that's why it's the limiting. Another way of thinking it that of thinking or rather understanding that, ne? We are saying we have less than
first, and once it, because it's in less quantity, right? So it runs out and then it leaves the brain alone. So that's why we call it the limiting. Understand? The amount that is available is less than what we actually need. Whereas the bread is going to be in excess because the amount that is available is more, right? Is more compared to the amount of cheese that we have. The amount of cheese that we have needs 4 slices, but us we have 8 slices. So it means we have more than what we need. Right. Guys, you have to sleep on that, you have to meditate on that. But this is one way of doing it. There is also another way. On our next lesson, we'll explore it. Critical means the other one is the excess. So um for someone who said no, I don't want X, so they will, so we don't need 8 slices. So there is more bread than what we need. Nah, look at here. You have more number of moles that are available than what you need. It tells you that from the 0.3 moles, 0.5 is going to take part in the reaction, and then it's going to leave how much? How many moles are going to be left in excess? You can actually calculate by saying the ones that are available minus the ones that are needed. So the ones that are in excess is going to be the ones that are available 0.3 minus 0.25, which tells us that you're going to have 0, some of it, right? So this is the situation here. So this tells us that nitrogen is the excess reagent. We've proved nitrogen is the um, excess reagent. It's in excess, and 0.05 moles are in excess. By the way, you can
usually you're going to be asked to calculate the moles in excess. So this is that's how you do it, and you do it for excess reagents. Ne? So here we have proved that nitrogen is the excess reagent. But for someone who chose to work on hydrogen, since they found out that hydrogen was the limiting, do you remember that they concluded that nitrogen was in excess? And right now we've actually proved that nitrogen is in excess. So whichever way you want to solve it, it's up to you. You understand? You're just going to find some interesting results. But I just need you to know, in summary, if the number of moles that are available, the ones you calculated first, if they are more than the number of moles that are needed, I just want you to think of the bread, that you have 8 slices and you only need 4. And if you have 2 cheese, so available is greater than what is needed. So that tells an excess reagent. You have 8 slices, but you only need 4. But if that are available are less than the number of moles that are needed, so then that limiting reagent. That one is a limiting reagent, because those that are available are less than what is needed, so they're gonna run out fast, right? So these ones, they run out first. Why? They are in smaller quantity. Smaller quantity than what is needed. Yes, you can ask Mr. Kevin. Yes. Why is it important for you to know which one is a limiting and excess? That's where we're coming to say. Now that you know how to determine a limiting and excess, please know that for any other calculation, you have to use the limiting reactant. You cannot use an excess reactant in the molar ratios for all other questions, okay? You have to use the limiting reactant. Hydrogen was the limiting